We got 5 problems. And if you do have questions while we're working them or while you're working them, you put them in the chat. I may be able to hear y'all today, so you can say it if you need to. I think I have the volume on. Yeah. Um, but we'll look at these 5 problems first. So the first one, I don't know why it's so much larger than the other ones, but it's 4 times 3x minus 1 is equal to 16. Second one's 7x minus 2x minus 1 is equal to 2. Third one, you got some fractions to deal with. It's x over 3 minus 1 over is equal to x divided by 2 plus 7. Fourth one is x plus 9 times x minus 1 is equal to x plus 1 squared. And then the last was x times x plus 3. Oh, sorry. X times 1 plus 3x is equal to 3x minus 1 times x minus 3. So give those a shot. One first. So the first thing for number 1 is we have this 4 times this algebraic expression here. The right-hand side is basically done for us, right? It's just a constant equals 16. So what we're going to do is take this 4 and distribute it. So the 3x is also going to go to the negative 1. So what we're going to end up with is 4 times 3x, which is 12x, minus 4 times 1, which is 4. And that's still equal to 16. And then now if we look at it, left-hand side, we have a term with a variable in it. We also have a constant there. And the right-hand side is just a constant. So I want to move my constant to this side. So to do so, I need to add 4 to both sides. And so we'll have 12x is now equal to 20. And to solve that, we want to isolate the x by itself. Right now, times 12. So we're going to divide both sides 12. And we get x is equal to, we can reduce that and make that 5 over 3 if we reduce both 20 and 12 by 4. And so my solution set is going to be a set containing 5. Any questions on that one? Oh. Yeah, let's look at number 2, which I think I hit behind. Nope. 4. There it is. So let's grab that. Right, so number 2, the big thing here, you got 7x, and then it's minus this whole algebraic expression right there. It's minus 2x minus 1, and that's equal to 2. So the right-hand side is just a constant. Nothing to worry about with that. We'll worry about it later. But since it's minus this whole algebraic expression, that negative is going to distribute to that second algebraic expression. So it's going to be 7x, and it's going to be minus 2x, and it's going to be minus a negative 1, which is going to end up being plus 1. And that's equal to 2. And now on the left-hand side, we got some common terms, right? I can combine these. I can evaluate this. I got 7x minus 2x. That's going to yield, what, 5x? We're going to keep plus 1 for now. So 5x plus 1 is equal to 2. Get all the constants on one side. We'll achieve that by subtracting 1 from both sides. We get 5x is now equal to 1. So we got all the terms with a variable on one side, all the terms with constants on the other side. Isolate the variable by dividing by 5 on both sides, and we end up with x is equal to 1/5. And so my solution set for this one is a set containing 1/5. Any questions on 2? You just subtracted the whole 2x minus 1 at the beginning. What do you? Oh, you added it to both sides? Hey, you could have did that. Let's see. So if you're saying you take that and you just add it that to both sides. And so you end up with what, 7x is equal to 2 plus 2x minus 1. You could do that. I mean, you should end up with the same thing. Is you end up with what? Minus 1. And so you have 7x is equal to, you can combine the 2 and the negative 1 there. So, right, that would be 1 plus 2x. And subtract 2x. And then we end up with a familiar part right here. You know, divide by 5, divide by 5. The only thing I would worry about is it's not that bad if adding this, okay? And I think it works out okay for that. But if you were given a problem that was like 7x plus, let's say 3x minus, wow, I changed the numbers halfway through. Minus 5 is equal to, I don't know, whatever. If you decide to do the same thing here and you subtract that, then you end up in a similar situation, because on this side, once you're done, you have 7x is equal to 3 minus 6, minus 5. Oops. Then this negative is going to distribute again. So you got to be careful with it. But I mean, it's not wrong. You can do it that way. It'll work out. Any questions on anything? Or any other comments, different ways somebody did it? Oh. All right, number 3. All right, so number 3 is difficult just because it has fractions in it. That's what tends to mess people up the most in this one. But what we got to do is try to figure out what can we multiply both sides by to get rid of the fractions. And so our denominators here are 3 and 2. And so if you're trying to find LCM of what to multiply by to get rid of 3 and 2, it's going to be 6. Yep. Okay, they don't have anything in common, so you just multiply them out. That's going to give it to you 6. And so we're going to multiply both sides of this equation by 6. And so let's write it out. So we're going to have x minus 3 times 6 minus 1 times 6. So the big thing that people forget to do is distribute the 6 to the 1. I think that's like the most common error there. So make sure you do that. Is equal to x plus 2 times 6 plus 7 times 6. Okay, so 6 is going to go everywhere. Now what's going to happen? Well, let's see. So here the 3 and the 6 will reduce. The 3 would be a 1. The 6 would become a 2. So we're going to have a 2 times x left. So that's going to give us 2x. Here we're going to have negative 1 times 6. Not much to do there. It's just going to be minus 6. On this one, the 2 and the 6 will reduce. This can become this will become a 1. This will become a 3. And so you're going to have x times 3, which is going to be 3x. And then don't forget the 7 times the 6 as well. So this is going to be plus 3. Now from here, we got a lot of options because both sides have a term with a variable and both sides have a constant. So you can kind of pick and choose which way you want to move this. What I decided to do is I decided to subtract 2x. And so what I end up with was negative 6 is equal to x plus 42. If you wanted to move the 3x, you could have. If you wanted to move the 6 or the 42, all of those are viable options. remember, just the goal in mind is to get all your variables on one side, all your constants on the other. So my next step here is going to be subtract 42. So I'm going to end up with negative 48 is equal to x. And so my solution set to be the set containing negative 48. Any questions on that problem? No? Good. Number 4. So number 4 has the looking like it may be a quadratic equation. But what we need to do, since neither side is equal to 0, is we need to expand both sides and see what we can do from there. We'll make an assessment after we do that and figure out what we're going to do. So if we expand both sides here, you use FOIL, first outer inner last, whatever you can use, but you end up with x squared plus 9x minus 1x and minus 9 on the left-hand side. Right-hand side is going to be x squared plus 1x plus 1x plus 1. Did I do plus 1? Yeah, okay. And we can combine some like terms. We got 9x minus 1. We can combine those. We have x squared plus 8x minus 9. And on the right-hand side, 1x, 1x. So we'll have x squared plus 2x plus 1. Okay. So it's still looking like a quadratic equation, right? We got x squared on both in the equation. But the thing is, you have an x squared on both sides. So if I subtract x squared from both sides, those will both just cancel out. And so what I'm going to be left with is 8x minus 9 is equal to 2x plus 1. And so what you end up with is a linear equation. Kind of the same situation we just talked about on the last one. You got x, you got variable terms on both sides, you got constant terms on both sides, so you can pick and choose what you want to do here. I like to keep my variable positive if I can think about it to do it. So I'm going to subtract 2x from both sides. We'll get 6x minus 9 is equal to 1. And we'll add 9 to both sides. And so we'll have 6x is equal to 10. And divide both sides by 6. Isolate my variable. X is going to equal, let's reduce 10 and 6. They're both reducible by, or both divisible by 2. So it'll be 5 thirds. So my solution set, that equation, is a set containing 5 thirds. Any questions on 4? And one more. Wherever I put it, there it is. Oh, sorry. There was some like water on my touchpad and it just went flying. All right. So number 5, similar situation. We're going to try to expand both sides before we do anything. On the left-hand side, you got an x that needs to be distributed. Right-hand side, you got the product of two binomials, so we have to do whatever system you want to use, first outer inner last, whatever you want to use for that. So if we distribute this x, we have x plus 3x squared, and now if we expand this side, it's going to be 3x squared minus 1x minus 9x and plus. So be careful on that. I can see that plus 3 messing people up. It's a negative 1 times negative 3. That's going to be a positive 3. Let's see what we can do. Left-hand side, can't combine anything. That's just going to stay the same for the time being. right hand side, we could do a little bit of work. 3x squared, don't have anything to combine with that, but I have a negative 1x and a negative 9x, so that's going to give me a negative 10x. And we still got a plus 3 hanging out. Indeed. So, similar situation to what we had last problem is an x squared term, so it looks like a quadratic equation as of now, but if we subtract the 3x squared from both sides, because it's on both sides, that's going to cancel, and what results is just x is equal to negative 10x plus 3. So we end up with a linear equation in the end. And so we worked that one out. Notice, I'll leave that up a little bit. Notice how on the left-hand side it's just an x. So it's a lot easier to say, well, I'm just going to move all the x's there since there's no constant. So I'm going to add 10x to both sides. And we'll have 11x is equal to 3. And divide both sides by 11. So x is going to equal 3 over 11. So the solution set will be the set containing 3 over 11. Now, it's not wrong if you subtract x from both sides and then move 3 wherever else you go, but as long as you're not breaking any of the rules we discussed, you should get the same answer. It may be more difficult of a route to take. Just different ways to do things. Any questions on any of those? No? All right, second page. It's everybody's favorite thing, word problems. So these are word problems that are designed to be, zoomed in one too many. Designed to be modeled by a linear equation, okay? So we did some of these in class. Remember, you go through, find the numbers they give you, the values they give you, find the relationship, and try to write it out as a linear equation. And then once you've done that, see if you can solve it. So give these a shot. Give you a few minutes. So Mary and her brother John collect foreign coins. Mary has twice the number of coins that John has, and together they have 120 foreign coins. How many coins Mary has? Okay, so it's a number they're asking you for both, which is odd, but just wants to know how many coins does Mary have. So things that we know, it's just Mary and her brother. Mary has twice the number of coins that John has, and combined they have 120. And then they want to know how many does Mary have. That's the things we want. So what I did was I made two variables. M for Mary and J for John. Now, I mean, you can use whatever variables you want. It's just what I picked. If it's not a special letter, I'll usually just use the first letter of someone's name if we're talking about a person's name. Now, we know that together they have 120. So we know that M plus J should be 120. Second bit of information they give us is that Mary has twice the number of coins that John has. We can represent that as saying, well, M has to equal twice J, which is saying 2J. So M is going to equal 2 times J, or just 2J. Any questions on setting that up? So in both these equations we have set up, we have two variables, and thus we can't solve it. When you have an equation with two variables, you can't solve them, but we can combine these together. If we know that M is equal to 2J, I can replace that M with 2J. And so we'll have 2J plus J is equal to 120, which is going to yield 3J is equal to 120. Oh, 120. And so if we want to solve that, divide by 3, we'll get that J is equal to 40. So we know that John has 40 coins. The question that they wanted to know, the answer to, was how many coins does Mary have? Well, can we figure that out? Well, we got two different ways we can do it now. We can go back to this one, plug in the 40 here, subtract the 40 from both sides, you get m is equal to 80. You could also plug in the 40 here. 40 is going to be 80, so Mary has 80 coins. So either way you want to go about it. In this problem, both are easy to solve once you have that first value. And so it really doesn't matter. Sometimes different equations are easier than others, but this one's not too bad. Either way, go with it. Any questions on number 6? No? All right, number 7. This is one I can see people having trouble with. So an auto repair shop charged a customer $527 to repair a car. The bill listed $87 for parts and the remainder for labor. So if I say P is equal to parts and L is equal to labor, we already know that the parts is $87. Let's read further. If the cost of the labor is $55 per hour, how many hours of labor did it take to repair the car? So for the labor, we're going to say, well, that's $55, but it's per hour. So let's do H as the number of hours. And so our cost of repairing a car is $527. We know that that is going to equal the parts plus the price of labor times the amount of hours of labor there is. Maybe we should make this a capital L so that way it doesn't look like a 1. And we know some of these variables already. We know P is 87. We know that is $55 per hour, so we can make that 55 times H. And so if we write this out now, a little simpler format, this would be 527 is equal to 87 plus 55H. And now what we end up with is a linear equation with one variable in it, that variable being H. And so what we're going to do, subtract 87 from both sides. I think that is going to be 440. And divide both sides by 55. And what you get is that H is equal to 8. So it's 8 hours. Is the amount of time they spent on labor. Any questions on that? It's a pretty useful example. I mean, if you do go to a mechanic and they don't show you how many hours, it'd be good to figure out. And, I don't know, maybe you left your car there for 2 days, or let's say you left your car there for 1 day and they charged you for 14 hours labor. Like, well, maybe that's impossible. So you can kind of use that in the real world. Any questions on 7? Nope. All right, so starting with 8, which I believe is on another page. Yep. There we go. We're going to start looking at some of the quadratic equations. So you got 6 of them here. How many we got on the next page? It's like 3 or 4. Yeah. So 6 of them here. The next page is ones I made up that I thought would be hard. So give these 6 a shot. All right. So first things first, and this first one could be tough even. I mean, it doesn't really fit a lot of stuff we did, but it looks simple. I think it's kind of deceiving. So this first one is you got 2x squared minus 22 is equal to 0. There's a few different ways you can work on this one. the first thing I did was it's already set equal to 0. So I'm thinking, let's try to factor it and see what we can do. And so when I look at this, and you may have done this differently, which is fine, but I see this from the 2, and this from there's a 2 as well. So I'm going to factor a common term of 2 out. And what's left is going to be x squared minus 11 is equal to 0. Okay? And from here, I'm like, okay, well, it's 2 times x squared minus 11 is equal to 0. And zero product property tells me that either this or this is equal to 0. I know that 2 can't equal 0, so I can say, well, x squared minus 11 is equal to 0. Okay. And now I'm looking at, well, can I factor this x squared minus 11? And it looks like it should be like the difference of 2 squares, but it's not. 11 is not some number squared, so I can't do that. And part of me thinks that maybe this problem was a typo. But I mean, I didn't write it. It was on a worksheet. So what can we do from here? Well, can't factor it. So let's try and see if we can do the square root method. Like, we only have that term of x squared. So let's see if we add 11 to both sides, and we end up with x squared is equal to 11. Now, since it's just a term of x squared, it's equal to some constant, and that constant's is non-negative. Remember, it can't be negative. We can apply the square root method. Take the square root of both sides, decide that is opposite the variable. It's going to be plus or minus. And so we just end up with x squared, not x squared at all, x is equal to plus or minus the square root of 11. And so a solution set here is going to be negative square root of 11, positive square root of 11. We can't evaluate the square root of 11, so that is going to be it. Quadratic formula would have worked on this one as well, but you didn't really need to go that route. This is a possibility. Any questions on 8? The other way of thinking about it is divide everything by 2 at the beginning, and then you get to that same point as we are right here. So that's another way you can do it. I was just trying to stick with the kind of the way that we've been working these out through class. Alrighty, let's look at 9. Well, it's not. Oh, there it is. Okay. Let's move these around. I have to go find these. All right, 9. So for this one, we have that form we always talk about: ax squared plus bx plus c is equal to 0. It's already equal to 0. That's good to go. It's not set up to be done with the square root method because it's not some term of x squared is equal to some constant. So when I saw this one, I was like, well, let's try to factor it. And so AC is going to be 5 times negative 4, which is negative 20. And B is positive 8. So remember, I want things to and multiply to equal negative 20 and add to equal 8. And I always think 5 and 4, but that's not going to work, right? And so I'm like, well, it's got to be something different. And then I thought, well, it's 2 and 10. Right? And since 1 needs to be negative, it looks like it needs to be a negative 2. Any questions on that? So we're going to rewrite our problem. This will be 5x squared. Let's just start it all over again. It's going to be 5x squared plus 10x minus 2x minus 4 is equal to 0. And if you wrote it 5x squared minus 2x plus 10x minus 4 is equal to 0, should get to the same answer, just a different path there. So now we're going to look at this first pair, 5x squared plus 10x. What can we factor out? What's in common between those two? Looks like a 5x. And I'm going to be left with x plus 2 remaining. Now what I want to do is factor something out of the second pair, negative 2x minus 4, such that I end up with x minus 2, x plus 2, sorry, as well. And so to achieve that, I would need to factor out a negative 2. Okay, any questions on getting there? Oh, all right, so once we're there, we have to move some of these. Once we're there, I have x plus 2, x plus 2. I'm going to factor that out. And what's left over? 5x minus 2. So that's going to be my other binomial. And so what we end up with is x plus 2 times 5x minus 2 is equal to 0. Zero product property applies here. So this is going to be x plus 2 is equal to 0, or 5x minus 2 is equal to 0. And then we just have to work out both of those linear equations that results there. We'll get x is equal to negative 2, and x is equal to 2/5, 2/5. And so my solution set is going to be, let's try that one again. My solution set is going to be a set containing negative 2 and 2/5. Questions on what problem was that? 9. Well, we're all good. All right. So I need 10 on the worksheet somewhere. Or did I throw 10? Is it hiding behind one of the other ones? No? I would zoom out and find it. Doesn't like that. This is what we'll do. Boop. Oh, did I delete 10? Oh, it's hiding behind 12. Okay. Let's put these in some order. There we go. All right, so 10. The problem with 10 is you start off with fractions. Why would it be a negative 2 that you take out? Let's see. Whoop. So, oh, you're talking about here. Okay, I got you. So I want this to be the same here. I want both of these to be the same binomial, right? So that way I can pull that out and have this here. And so when I pull out the 5x between these two, we end up with x plus 2. And so to get this to be an x plus 2, I would need to factor out a 2, right? But because they're both negative and I want them both to be positive, I'll factor out a negative 2. Does that make sense to you? So if you want to change the sign, either from negative to positive or from positive to negative, yeah, you want to make sure you pull out a negative value. Maybe you had like 2x plus 4 or something like that, then yeah, that'll mess you up. All right. Number 10. Got x minus 4 divided by x is equal to 15 over x plus 4. So problems here is we have these rational expressions on both sides. We want to get rid of that, but before you do that, make note of your domain. So currently, with the equation that they gave us, x cannot equal 0 and x cannot equal negative 4. We need to keep that in the back of our minds. If we do get those as a solution, we need to get rid of those solutions because they are not valid for the original equation we start with. So that being said, the next thing we want to do is we want to get rid of those denominators and not have a rational expression on both sides. So to do that, one side has an x, the other side has x plus 4. Nothing in common between those, so we're just going to multiply both sides of this by x times x. What's kind of nice about it is you only have one term on each side. There is another method of working these out. What do they call it? Cross multiply. So if you know that way, that's fine too. The only thing is cross multiplication only works when you have a single term on each side like we do here, but it doesn't always work for every equation with rational expressions. So on the left-hand side, this x and this x will reduce, and so we will be left with x plus 4 times x minus 4. On the right-hand side, x plus 4 reduced by x plus 4, and we're going to be left with the result of 15 times x, so 15x. Questions on up to there? All right, let's keep going. Left-hand side, going to expand that out. You can see that it's the same binomial, just with the sign change. So you're going to end up with x squared minus 16 is next. And now we have our quadratic equation, but not everything is on one side. One side is not equal to 0. Let's get it there. So let's go ahead and subtract 15x from both sides. And still end up with, let's write it here, x squared minus 15x minus 16 is equal to 0. Now it's in that ax squared plus bx plus c is equal to 0 form that we want. Let's see if we can factor it. So AC here is going to be negative 16. Bravo is going to be negative 15. One thing is that multiply to be negative 16, and things that add to be negative 15. For some reason, my brain wasn't thinking. I took a while to figure this one out, but it's going to be 16 and 1, and it should be a negative 16. And so let's rewrite that. Well, we're doing green now. And it's just going to be x squared minus 16x plus 1x minus 16 is equal to 0. And just like we did in the problem before, we're going to take a look at that pair of first two terms. What can we factor out of those? What do they have in common? Just an x. And so we're left with x minus 16. Notice that this one is already x minus 16. So that means we're going to factor out a positive 1, which I'm going to rewrite because it looks like an h. Let's just do this whole part here again. There we go. So now, x minus 16 here, x minus 16 there. Let's pull those out. And so we'll have x minus 16 times what's left over, x plus 1 times x plus 1 is equal to 0. And so that's going to be an application of the zero product property. And so we'll have x minus 16 is equal to 0 or x plus 1 is equal to 0. Yep. And that's going to result in what? Either 16 or negative 1. Neither one of those is in our domain restrictions. Remember, our domain restriction was negative 4 and 0. So those are valid solutions. And we're good to go. Any questions on 10? I might not get to 13, but I'll give you an answer. We should get through the next two. All right, 11. 11 is interesting. There's a few different ways to go about this one. You could expand the left-hand side You get this, normal quadratic equation and work it out from there. The other option is on the left-hand side, it's a term of x squared. On the right-hand side, it's just a constant, and it's a non-negative constant. So that means that we could take this. I'm going to rewrite it to give myself some space. And just do the square root method. We're going to take the square root of both sides. The side opposite the variable is going to be plus or minus. And so what we end up with is 2x minus 1 is equal to plus or minus, and the square root of 81 is 9. This becomes two linear equations. So this is going to become 2x minus 1 is equal to positive 9, or 2x minus 1 is equal to negative 9. And we need to work out both of those. So add 1, and we'll have 2x is equal to 10 divided by 2. X is equal to 5. Off to the second one. Add 1 on both sides. You get 2x is equal to negative 8 divided by 2. And x is equal to negative 4. And so your solution set for that one will be 5 and negative 4. So that's an interesting one. You can work it out a few different ways, but if you notice that you can do the square root method, it's a lot quicker and maybe even easier. All right, any questions on whatever problem that was? 11. Let's go on to 12. I placed it somewhere. There it is. So we have x squared plus 5x plus 2 is equal to 0. This one is set up perfectly. Ax squared plus bx plus c is equal to 0. Let's try to factor it. So we're going to say AC is going to be 1 times 2, which is 2. Bravo is going to be 5. I need things that multiply to be 2 and add to be 5. Now the only possibility for things to multiply to be 2 is 2 and 1. And there's no way for me to take a 2 and a 1 and make a 5. So that means I can't factor it. Once we realize we can't factor it, that's when we go, okay, let's talk about the quadratic formula. And so the first step when you're doing a quadratic formula, we want to look at the discriminant. E squared minus 4ac. So for us, it's going to be 5 squared minus 4 times 1 times 2, which is going to be 25 minus 8, which is 17. That 17 tells us that we're going to have 2 real solutions. Okay? To find those 2 real solutions, we have to continue on. And so with the quadratic formula, x is equal to negative b, so that's going to be negative 5, plus or minus the square root of the discriminant, which we already found, which is 17. And then all that is over 2a. A was 1. That's going to be 2 times 1. And so that is going to end up being negative 5 plus the square root of 17 over 2. I can't do anything to reduce that 17 to evaluate it or anything. 17 is just 17 times 1. So I can't do anything with that. That's just going to be my solutions there. Any questions on that? All right, let's get 13. We can make it, I believe. All right, so 13, excuse me, same situation. You try to factor it, you can't. But before you start, you do want to move everything to one side, which I forgot to tell you. So you do want to get into that form, right? Ax squared plus bx plus c is equal to 0. But if you try to factor this, you cannot. And so we're going to try to do the quadratic formula once again. Remember, I want to check my discriminant first. And so that's going to be 6 squared minus 4 times 2 times 3, which is going to be 36 minus 24, which is going to be 12. Once again, it's a positive number as a result of my discriminant. So that means I got 2 real solutions. How do we find those 2 real solutions? Well, we keep trucking with the quadratic formula. So that's going to be x is going to equal negative 6 plus or minus square root of 12 over 2 times a, which is 2. Now, here, let's keep working on it. Let's see what we get. Still going to be a negative 6 plus or minus. Now, the square root of 12, we could write that as, well, let's do it this way, as 4 times 3, right? And then it's over 4. Now, we could take the square root of 4. The square root of 4 is 2. So we can evaluate that some more. It's going to be negative 6 plus or minus 2 square root of 3 over 4. And remember, I told you that if you can reduce every term in the numerator, this term and this term, then you could reduce it. And so 6 is divisible by 2. 2 square root of 3 is divisible by 2. And 4 is divisible by 2. So we can reduce everything by 2. This will become a 3. That's just going to be a 1. And this would be a 2. And so my final answer is going to be negative 3 plus or minus the square root of 3 all over 2. And so you need to be able to reduce those answers if you can.